final part of question 10. So you've got 300 runners, they've each got a number on them, so 1 to 300, and you need to pick 2 of them so that when you add their numbers up you make 101. So if you pick the person with the number 1 and the person with the number 100, that makes 101. You can do the same with 299, you can do the same with 398, you can keep going all the way down to 50 and 51. And you can say, how many pairs have I got? You've got 50 pairs. So those are the pairs that work for you. You can't pick a person greater than 101, it just doesn't work. So you need to be sticking down here. So 50 choices, that's fine. Out of what? Well, you've got 300 runners, you're choosing 2 of them. So if you do 300 choose 2, you get 44,850. That's how many different combinations you can make, and 50 of them work for you, giving you the 101. So it's just 50 out of that number, which simplifies down to 1 in 897. Now, there is a quicker way, which is just pure probability. So to start out, there's 300 people. If you pick any of 100 of them, then that works for you. So you can pick number 1, number 2, number 3, number 4, and you can still make 101. You can't pick 101 though, because when you pick the second runner, you'll go over 101 when you add it on. So anyone from 1 to 100 is grand. And then once you've picked that person, you need to then pick the only person there that will make a pair with them to make 101. So for example, if you pick runner number 3, you have to then pick 98. Nothing else will work. So this number 3, you've got a 100 in 300 chance of doing that, because you can pick any of them. You can pick 3, 99, 51. But once you've picked your first person, like 50, you have to then pick the 51. So that's where the 1 comes from. And the 299 is because you used to have 300 runners, but you've chosen one here, so it's only 299. And that gives you the answer straight away. So either or, they both work. Okay, on to the very, very last thing. So this is Saoirse running a marathon. So let's just get that on the screen. Yeah, that works. So the windy marathon, you have all the information. The sunny marathon, you don't. You just need this last little bit. So windy marathon, 5265. So there are 5264 people with a smaller, faster time. And the reason why I'm saying smaller or less than is because if you look at this thing, we're always interested in smaller and less than. Okay, they're shaded in a bit. So normally distributed, which is at the top. I underlined that as soon as I saw it. I was like, yeah, normally distributed, brilliant. I'm going to use my z-scores. So we'll come down here. Right, we need the time, and that's the game, I suppose. So 5265 out of 6,000 gives this percentage, or decimal, which could be a percentage. So 87% of people have a smaller time than Saoirse's time. So if we look up the 87 on the z-scores, we're looking up, so 0.877 is what we had. So we look this up. So this is 1.16 is our z-score. It's the closest. Even though we've got a 3 on the end, it was still the closest. So this is our z-score. We're looking for her time. We've got the mean. We've got the standard deviation. We do a little bit of algebra. We move the 38 up there and multiply. We move the 254 and add it on, and we get x as 298.08 minutes, and that's her time. Then, because the times are the same for the sunny marathon, we just come down and say, okay, I'm going to put this time into exactly the same formula. It'll give me a z-score. You use the different standard deviation though. You use the different mean, and you'll get 1.76 for your z. You look that up then in the z tables. Okay, so I'll show you how to do that. So 1.76, we come here. There's 1.7. There's the extra 6. So you just see where they meet. So that's here. So 0.9608. So that's the percentage of people with a smaller, faster time. So that's fine. So then we say, okay, if 96% of people, let's just move that, if 96% of people beat her time, or were ahead of her, then what would her position be? So if there's 2,000 runners, you just find that 96% of 2,000 runners, and you find that she came in 1,922nd. So I could put that in the table, I just haven't. That is the answer.